Started. All right, so that we're just gonna go over a couple more questions from change of date. We left off from last week. Yeah, we're gonna get to some of the questions that require solving like this, right? Okay, so let's start with this. All right, so this is a typical exponential equation, right? And we try to solve for x. And right here, first of all, we're gonna get variable x by itself. So what we want to do is taking a log with a base 10, right, from both sides of the equation. That'll be the easiest to do, but in this case, so let me share the screen. So going back here, you're taking the log with base 10. Log 10 is 9 minus 5x. That is exponent on the right hand side is log 10, 10. And log 10, 10 would become 1. And here, 5 minus 5x goes in the front. This is exponent. 5 minus 5x is log 10, 5. Right? Now from here, we're going to distribute it and isolate the variable x and then solve for x. So 5 times log 10, 9 minus 5 times log 10, 9. That's x. And that equals 1. And next up, usually it's easier, right? Removing the x to the other side, but it's okay. So we're just going to subtract by log 10, 9 on both sides of the equation. Cancel that. We get minus 5 log 10, 9. That's actually equal to 1 minus 5 log 9. And we divide both sides of the equation by minus 5 log 9. And cancel that x is by itself. Now we can multiply both top and bottom by -1, right? So we're gonna get the reverse, which is 5 log 9 minus 1 over 5 times log. Okay. And still they want to run to 3 decimal place. This is where you need to use a scientific calculator. Yeah, I'm gonna show you how to get that. You can go to the Google, right? Type in absolute scientific calculator. Let's open the calculator. And we can put in the answers here. So it will be 5, open parentheses first. 5 times log 10, 9. And here there's a log by default is a log 10, right? Okay, and close parentheses. And yeah, minus 1. 1, and close one more parentheses. Denominator is going to be log 10, 9. So go back to function, log 10, 9. Close parentheses. And that would be the answer, right? 3.952. Yeah, that's going to be the answer for this question, 3.952. So the approximate answer is 3.952. Check the answer. Oh, correct. Why? Let's see. 3 decimal place. should be, yeah, let me double check with the work did. Okay, let me see. Oh yeah, 5. I forget to put a 5 in front of log 10 now. Yes, or the denominator, that's why. Go back to that scientific calculator. I forget to put a 5 here, that's why. So that will be 0.790. We run 3 decimal place. 0.790. Go back here. 0.790. That should do it. Yep, it is good. Okay, so you guys try one of those, right? Show me another. Yep, let's try this. While you're doing this, I'm calling attendance, right? Hi Ted. Hi Ted, are you here? No. Abra. Abra is here. Okay. Amaya. And the mutual.
Here.
Okay, very good. And Daniel.
I'm here.
Okay, great. And Sapimonia.
Here.
Peter.
I'm here, mister.
Okay, sure. Okay. Ivan.
Here.
Tom.
I'm here.
Great. Count.
Yes, I'm here.
Okay. Victoria. Victoria. Okay. Li Shen.
Yes, I'm here.
And Guang Yu.
I'm here.
When I say that, definitely computer science is a science.
Okay, very good. Okay, everybody on your attendance. And let's go back and solve this problem here. So one more time.
Sir, sorry. Do you tell me just now?
Yes, Guang Yu, I mark you present.
Okay.
Yeah, okay. So
Thank
we'll go back to, no problem. Yeah. Go back to this question. So one more time, we're gonna take the log 10 from both sides of the equation. Because this one is a 10, right? That's why log 10 will work best. So this 9, 5 minus 7x. And that's equals to base and the power and the base for the exponent are the same now with the 1. 10 to the 1 is equal to 10. So here is a 5 minus 7x times coefficient log 10. Now distribute it, and then we're gonna get 5 times log 10 minus 7 times log 10 times x, that's equal to 1. Then subtract 5 log 10 both side equation. Now we get minus 7 log 10 that's x equal to 1 minus 5 times log 10 and divide both sides of the equation by minus 7 log 10 So we simplify a little bit, now we get the result 7 log 10 just cancel this common the center in front, and eventually we end up with and then simplify this, right? Just multiply -1 here and then -1 on the bottom. And now we will end up with x equal to -1 times 1, that's 1, right? 1 plus 5 times, no, -1. So we do, this one become negative. So then this one become positive. So you write positive one first, 5 times log 1. Next one on the bottom, 2 -10 is positive, 7 log 10. And we're gonna put it into the calculator. But you can also put it into the calculator. We have a sign with the calculator. Here I'm just gonna put in decimals. In decimal, you can even copy paste, right? I'm just gonna copy paste because it's just one minor difference on the denominator. So it's becomes 7. And once you enter, you get the answer, right? 0.565. When you run into 3 decimal places, because 4th decimal place is 5, so you add 1 to the 3rd decimal place, make it 0.565. So it's 0.565. Yeah, that would do it, right? Calculate. Let's move on to next question. It is similar, just very similar. So I just skip it, right? And this is something new. So let's work on this. This is something we haven't done yet. So let's see. 27,243. Yeah. Let's look at this. So first of all, it's easier to turn into a exponent, right? In this case. So you do 27. So assuming this equal to x, we don't know what that is. Assuming it's x. So it'll be 27 to the x equal to 243. And we know 243 is 3 times 81. 81 is 9 times 9. And that's 3 times 3 times 3, 3, 3. Meaning 3 to the 5th power. And we see why we do this, right? Because you're going to decompose into the smallest prime factor here, so that we do the same thing for 27.
Excuse me,
Because
sir, we cannot see.
okay, gotta share. Okay. All right, go back here. Yeah. So again, 243 equals 3 times 81. 3 times 9 times 9. And it becomes 3 times 3 times 3 times 3 times 3. 3 to the 5th power. And the reason why I do that, because 27, right? This 243 cannot be written as 27 to whatever power, right? It's not easy to do that. You can write it as a fractional power, but it's a very complicated process. So it's easier to decompose 27 and 243 to the same base. So 27 is 3 times 3. So that's 3 cubed. Now they have the same base, right? This is what we want. 3 cubed equal to 3 to the 5th. Now we get 3 times x is 3x, 3 to the 5th. Now same base, power must be the same, 3x equal to 5. Now divide 3 from both sides of the equation, now x equal to could be over 5, or 5 over 3. Do you have any question about this? 5 over 3. This one we can leave as a fraction, which is that fraction, which is good. All right. Let's see. Maybe you guys try one of this, right? All right, let's go over the solution here. So first of all, you can turn it back to exponents. We get the 4x, 4 to the x equals 32. Or we can do this. Another way of looking at it, without converting the 32 to base 2, right? We can do 32 is equal to 4 times 4 times 2. And 2 is 4 to the half. But again, it's harder to go doing this way, right? So usually, so it'll be 4 to the 1, will be 2.5, right? Oh, so which is 5 over 2. So 32 equals to this 4 raised to 5 over 2. So this is 4x and 5 over 2. Now same base is equal to 5 over 2. But again, this is harder to tackle, right? So usually it's easier to decompose 32 as 2 times 2 times 2 times 2 times 2. Yeah, so that will be 2 to the 5th. And then 4 is 2 to the 2nd. Now same base. And so it becomes 2 to the 2nd to the x equal 2 to the 5th. So 2 to the 2nd, 2x equal 2 to the 5th. Now same base, 2x equal to 5. And divide both sides of the equation by 2. X equal to 5 over 2. So same solution. 5 over 2 is the answer. Any question? Good. All right, let's move on to the next question. This is let's see. Compute. Yeah, this one we're gonna use change base formula. So let's try this. So I'm gonna try this one. So use a change base formula. Meaning that you can either change the base to LA or the log with the base 10, right? Either one you like, not a problem. So log 3, 190. It's gonna be times. Remember I showed you last time log 80. This is change base formula. So log C E over log C K. C the common base. And this is what we call the change base formula. And the reason why we need it is because all the computers and softwares are like scientific calculators was programmed using only base 10 or base E. And that's why sometimes we gotta use the base formula in order to get answer. So right here, we're gonna do log 10, 190 over log 10, 3. Okay. Now, from there, we just gotta use a calculator. There's no way to do it by hand. It's not easy. So log, and so go back to function and get log 10, 190. Close parentheses divided by log 10, 3. And we get about 4.776, right? That's the answer. 4.776. Approximately equal to 4.776. That's what we want. And then go back. 4.776. Correct answer. It's good, right? Let me see. Next question. This one. This one. Yes, you guys might try one of this, right? Log A 160. Okay. So one more time, you're gonna change the base. So will be a 60 equal to log 10 160 over log 10 8. Or you can, if you want to do ln, that's okay. You take ln log of the base e, that's equally good. Log ln of 160 over ln of 8. Or whichever you prefer, right? It's equally good. Let me show you both. You're gonna end up with the same result. So log, yeah, that is log 160 over log 8. Yes, we get this, right? Which is 2.441. If you're doing the ln, it'd be the same, right? ln of 160 over ln of 8. Yep, same result, 2.441. So the answer is 2.441. Put it back, check it. Go back. 2.44. That should do it. Yeah, that's good. And then one last question in the section will be this problem 8, right? So small city has a population 33,000 in 1994. The population growth after 1994 is modeled by this. This is called an exponential model, right? And so, what year will the population reach 66,000? So let's look at it. So basically, we are given this exponential function, and we want to know that time t, right? We will find out the time t. What year means t is unknown. We're going to solve for t here. And the population reached 66,000, meaning PT, when population at that year is equal to 66,000. I want to know what year that is, right? They start counting, they start using a model after 1994. And so here replacing this whole thing, right? This is the exponential model, 33,000 times e to the 0.06 t. That is equal to 66,000. And then from there, we're going to solve for t. So dividing both side equation by 33,000 first.
We cannot see the screen, sir.
Okay. Thanks for the reminder. I forget to share it again. There you go.
Yeah,
So one more time, sure, no problem. So P of t, right? That's a population after certain years at a time t, which is 66,000. So we're gonna write express that, and the population is modeled by this exponential function, right? 33,000 times e to the 0.06 times t. Now from here we are solving for time t. And so in order to solve for time t, first of all, you divide both sides of the equation by 33,000. Yeah. And then cancel that e to 0.06 t equal to 2. Now you're gonna take the ln because it's base e, right? So anything grows continuously. We are modeling using an exponential function with base e continuously. We model by exponential function with base e. E is whole number, right? It's also called a natural number. So the national debt, right? Every country borrows debt, and then national debt compounded continuously. Also, population compounded continuously. So those who are the real world phenomenon, especially population, right? People, this is a very, very important topic, population growth. And this all come from this natural number, right? Exponent with the base e, basically, natural number. And this natural number is like pi, so it's approximately equal to 2.718, A1, A2, and keep going, right? Just like keep going infinitely, just like pi, right? Eventually, pi has infinitely many decimal places. And right here, going back to our problem, it's just some kind of like background knowledge, right? You can have. And going back here, taking the Ln from both sides equation, E06t, and Ln of 2. Then this Ln is log with base e, right? So that's equivalent. It's just a quick abbreviation of this log with base e. So these two will cancel each other. So 0.06t goes in front. I get Ln of 2. I'll divide both side equation by 0.06. And we get time t right by itself. Let's see what that is. They want how many decimal? Oh, yeah. We're gonna run into whole number because it's the year, right? So we do that. But here, let's get Ln of 2 divided by 0.06. So that's 11.6, right? And then we just run it to 12 years. It takes about 12 years. So time t approximately equal to 12. They start modeling the population starting in 1994. So that's like the starting point. So you're gonna add 12 to 1994. So you get a 2006, right? So that means by 2006, the small city will double the population. Basically, this is doubling, right? 33,000 to 66,000. That's doubling. So it takes about 12 years to double the population. That's usually the case, right? Usually it takes about 10 to 15 years to double the population for the city, for the country. This is a very, very common case in the real world. And that's a pretty answer, right? Into the box here. Okay. 2006, right? That's the year this population will double, reach 66,000. That's double it. Okay. Any question about this? Okay, so I guess we're gonna move on to a new topic. Today we're gonna talk about the trigonometry, right? So that's the last topic we're gonna cover in this program. This is summer intensive program. So let's start with let me give you some brief introduction of the degrees, radians, special triangles, all that, before we jump into the actual content. Okay, so OneNote. Okay, so let's go to the note. Sorry. So let's start with the degree measurement and then radian measurement, right? And then the most important conversion is if you look at the circle, right? It's all based on the circle. So basically, circle. We know circle has, the degree measurement, 360 degree, right? And then the radian measurement is like, if it's unit circle, so it's 2 pi. So this is the degree measurement. And this is the radian measurement. And they form this kind of special relationship. meaning 2 pi equals 360 degrees, then we know divide 2 from both sides of the equation, then pi is equal to 180 degrees, right? So that's so that's how the mathematician build a foundation, starting from the degree measurement and radian measurement. So now divide by 2, right? And we cancel that pi equal to 180 degrees, right? So this is let's say this is the unit circle, and then that means 360 degrees, one cycle, right? One cycle equals 360 degrees is equal to 2 pi in the radian measurement. And we figure out the conversion between the degree measurement and radian measurement. Okay, and then next thing we're going to talk about special triangles, right? And special triangle, let's start with the 30, 60, and a 90-degree triangle. 30 degree, 60 degree, 90-degree triangle. And a special thing about this one is, say this is, yeah, probably a little bit narrower. It's, yeah, let me just redraw a little bit, just to make it. And let's say this is 30, this is 90 degree, right? Meaning this perpendicular to that. And let's say this is a 30-degree angle. This is 60-degree angle. And this is 90-degree angle. And we know that the sum of for all triangles, right? For all triangles, the total of all 3 angles, the measurement, the combined total will be 180 degrees. So, I mean, let's say this is angle A, angle B, angle C. For all triangles, angle A plus angle B plus angle C. For any triangle ABC, right? A, B, and C. And it's, when you sum up all 3 angles, you end up with 180 degrees. And then, but 30 and then 60 and 90-degree angle is a special one. Why is that? Let's think about this, right? I'm going to show you the geometry behind this, so you appreciate this a little bit more. How people come up with all those special values for this sine, cosine, all that stuff. It's not it's not exactly. So angle A, 30 degrees, right? We just measure that. Now, the most important thing is we're gonna turn into this. It's like what we call an equilateral triangle, right? So based on this, we're gonna form a mirror image based on this triangle here. So again, I didn't do a good job. It's hard to draw it by hand. So I have to get a very accurate. I think I can do it. Let's say we draw the exact same, like, so we get something like this, and then we're gonna form a equilateral triangle, right? This is a very important term. Equilateral triangle. Equilateral meaning all 3 sides are equal to each other, right? So let's say this D, right? So basically, AB equal to this. This is 30 degree. This is 60. This must be 60 degree. When all three angles are the same, then all three sides are the same. That's where this three angles equal to each other and three sides equal to each other. That means if angle A equal to angle B equal angle C, right? Then all three sides must be the same. That means AB equal to AC equal BC. Side. They all equal 60 degrees. This is called an equilateral triangle, right? And then as all three sides will be the same. AB equal to AC equal to BC. Right side. Angle. Now here we get an interesting discovery here. So let's assuming this is 2 units, right? And this is 2 units. And this right here will split because this equal to this, right? So this is 1 unit, this is 1 unit. Okay. So that means based on the Pythagorean theorem, we can find out this side here, right? This is 2 units. This is 1 unit. So that's based on the Pythagorean theorem. Pythagorean. It's based on Pythagorean theorem. In this case, it's AB squared, right? This side, AB squared is equal to AC squared plus BT squared. If you do, let's say this is the C. I think this is what you learn, right? B, this is A. And also, it's like a C squared. That's a silent letter for AB, right? Silent letter for AC, and then silent letter for BC. And AC squared equal to B squared plus A squared. So this is the Pythagorean theorem, basically. And based on Pythagorean theorem, we can solve for the side AC, right? So basically, we're solving for this. Now this is 2 units. 2 squared equal to B squared plus. Now A is 1 unit. We should use lowercase. This lowercase is better. We use a lowercase. Be consistent with the textbook. B squared and A squared. This is what you learn from the high school, right? You learn something like this from high school. And just quickly refresh your memory, what you learn. And B squared, right, equal to A squared. A squared, A is, we just assume this side BC as A, so it will be 1 squared. And then we're going to solve for B here. So this is 4 unit B squared plus 1. Subtract 1 from both sides of the equation. B squared equals 3. Now you take the square root from both sides of the equation, so B squared equal to, although theoretically there's plus minus, but in this case, we are dealing with the real world measurement. So it has to be positive, radical 3. We just eliminate the negative answers. So B equal radical 3. Now basically we find out the relationship, right? For all the 30, 60 degree, 60 and 90 degree angles, and we're gonna get something like this. This is A, C, this is X. I think I'm putting a different, yeah, I put C over there. AC. So this is the, right, so this is C, right? This is what we talk about. opposite side of this angle C, that's a lowercase c, and this is B, this is it. And this is 30 degree, and this is 60 degree, 90 degree, right? And basically, all the sine, let's say trigonometric functions, right? Three functions, trigonometric functions. So if you look at it, sine, right? Sine 30 degrees. In this case, it's gonna be the opposite, right? Sine is opposite over hypotenuse. So sine is opposite over hypotenuse. That's why P, right? And then cosine is adjacent, right? ADJ, adjacent over hypotenuse. And then tangent is opposite over adjacent. Right? Cotangent is the inverse, will be adjacent over opposite. And secant is hypotenuse over adjacent. Because secant is the reciprocal of the cosine, right? And cosecant is the reciprocal of the sine. And so the hypotenuse over opposite. So this is the requirement. It's like how we calculate all 6 trigonometric identities using the sides, right? So here sine 30 degrees, which is this, so it will be A, so we know A is 1 unit, C is 2 unit, B is radical 3 units, right? Square root of 3 unit. So sine 30 will be 1 over 2 half. That's why sine 30 is equal to half. And we just prove it using geometry, right? This is strictly coming from geometry, also the Pythagorean theorem, right? I didn't tell you to memorize this, right? You can actually prove this step by step. I'll just show you how to get to this. So you understand all the rationale behind this. It's not like just throwing at you, right? That's geometry involved. We're using geometry actually 5,000 years ago, right? Middle East, people from Middle East already, mathematicians from Middle East already used geometry to build a pyramid, all that stuff, right? So this is a very, very long story, but has a very, very useful applications in the real life. Yeah. And then cosine 30 degrees. And you see that cosine will be adjacent, right? Adjacent of this angle, this here will be radical 3, right? Radical 3 over 2. And the tangent 30 degrees. That's going to be tangent is opposite over adjacent, so it's 1 over radical 3. Opposite 1 over adjacent radical 3. And typically we're going to rationalize this, right? So it'll be 1 times radical 3. I'll change the color. It's not responding well. So over radical 3 times radical 3. Yeah, radical 3 over radical 3, right? And then we can get cotangent, and it's the secant cosecant, right? Cotangent 30 degree angle, and that will be adjacent over opposite. Or cotangent is the reciprocal of tangent. So it will be radical 3 over 1. That's going to be radical 3. Adjacent, it's radical 3. And secant will be reciprocal of cosine. So in that case, it will be hypotenuse is 2 units over secant 30 degree. Over adjacent, yes. Adjacent is radical 3 units. Again, we rationalize the denominator at 3, radical 3, 2 times radical 3 is 2 radical 3 over 3. Right? And then cosecant 30 degrees. Cosecant is hypotenuse over opposite, right? Hypotenuse is 2, opposite is 1 unit, so it's 2. And then now let's take a look at the 60-degree angle, right? If you look at the 60-degree angle, let's put it side by side. So the sine 60 degree, you look at this angle here with the opposite, which is radical 3 over 2 over hypotenuse, right? Hypotenuse 2 units. And as you can see, sine 60 is the same thing as cosine 30 degrees angle, right? Because they call this complement of each other. So they form this special relationship, sine 60 equals cosine 30 degree angle. And then also cosine 60 degree. So cosine 60 degrees, cosine is adjacent over hypotenuse, so it will be 1 over 2. So adjacent 1 unit over hypotenuse is 2 unit. And then tangent 60 degree will be the opposite, radical 3 over adjacent 1. So radical 3. And then cotangent 60 degrees is adjacent over hypotenuse. So adjacent 1 over hypotenuse 3. Right?
Professor, do we have to remember all these values?
Not really. Right? I just show you how to get it by yourself. But if you memorize that, that's probably bad. That will help, right? But you see, I just show you how to derive all of this from the scratch. If you just draw right triangle and we just develop from there. See, yeah. So you should remember the process, right? How people come up with all these trigonometric special angles, especially for special angles. How do we come up with this, right? That's more important to look at. Yeah. And then also secant 60 degrees, and secant is reciprocal of the cosine, right? So it'll be 2 over 1. You can say secant will be the hypotenuse 2 units over adjacent 1 unit. So that's 2. And then cosecant 60 degrees will be then hypotenuse 2 over adjacent, over the opposite, right? Radical 3. And it rationalizes, we multiply both top and bottom by radical 3. So end up 2 radical 3 over 3. And as you can see, there's a lot of interesting things. Tangent 60 equal to cotangent 30, and then tangent 30 equal cotangent 60, right? I see a lot of different interesting things. And secant 30 equal to cosecant 60, and secant 60 equal to cosecant 30. So that's based on the complementary angles, we have a lot of equal values here. Okay, any questions so far about this 30, 60, and 90 degree angles, special triangle? That's another one, right? Which is 45, 45, and 90 degree triangle. We're gonna look at that in a second. So 45 degree, 45 degree, and then 90 degree triangle, special triangle. And this one is actually slightly easier. We don't have to use too much geometry, right? We just use we call this this is what we call the isosceles, right? Isosceles triangle here, because this is 45 degree, this is 45 degree, and this is 90 degree. And that's putting, this is C, right? That's B, that's A. And because this is isosceles, triangle. Then A equal to B here, right? Because a 45 same angle meaning same size, right? These two angles are the same, then this is what this means. Isosceles triangle, and here A equal to B, and then we are assuming they both equal to 1 unit. This is 1 unit, this is 1 unit. And using the Pythagorean theorem, we can find out the C, right? Because there's a right triangle here, so using under Pythagorean theorem, D squared equal to B squared plus A squared. C squared equal to 1 squared plus 1 squared, which is 2. So C squared equal to 2. C equal to taking the square root of both sides equation. Square root 2. Equal to radical 2, right? And based on this, we can develop all the this special trig identities, right? Radical 2. So now for 45-degree angle right here, and we get this sine 45 degree is equal to opposite, right? Opposite is 1 over hypotenuse radical 2. Okay. Then we're gonna rationalize this. That's what that's how you see all this, right? That's in high school, maybe your teacher asks you to memorize this special geometric identities. And here, I'll just show you how to go step by step to figure out this yourself, right? So we get radical 2 over 2. And cosine 45 degree is the same, right? Will be the adjacent one, like B over C. So adjacent 1 over hypotenuse radical 2. So it's still radical 2 over 2. And tangent 45 degree, it's going to be opposite over adjacent. So it's 1 over 1, that's 1. Cotangent 45 degree is adjacent over opposite, right? So it's 1 over 1 as well, that's 1. And secant 45 degree, it's a hypotenuse over adjacent, right? Hypotenuse in this case is radical 2 over adjacent, that is 1 unit. So it's radical 2. Cosecant 45 degree is hypotenuse radical 2 over adjacent, but that's the also radical 2. Yeah, no, it's hypotenuse over opposite, right? Opposite is also 1 unit. And so cosecant is the reciprocal of this sine, right? So that's how this, and this is also interesting. Tangent equal cotangent, secant equal cosecant, right? Sine equal cosine. For 45 degree and 45 degree, 90 degree special triangle, we have this kind of relationship. Okay. Any question about this? All right, next thing we're gonna take a look at some of the examples, right, from the. So I'll just show you how to, and then we know that 60 degree is equal pi over 3, right? Because 180 equal to pi. And 1/3 of that would be pi over 3, right? That's why 60 equal to pi over 3. Yeah, so then 45 degree equal to pi over 4. We do 180 over 4 equal to pi over 4. Okay. 180 over 4 is 45 degrees. And let's go back to this homework platform. And then let's take a look at some of the exercise from section 10.1, special triangle. Yeah. Start with this. That's convert a degree measurement. Let's do another one. 45, no. Still 45. Yeah, let's try 36, right? And then how do we do this? Let's see. We just using this special conversion. So we want to convert 36 degree into the radian measurement, right? We know that pi equals 180 degree. Now we can use this as a like pi over 180 degree, right? We set up a proportion and solve for the unknown here. Okay, and then now we get 36 degree, and we don't know how many pi, right? How many radians? Yeah, I forgot to share. Yeah. So pi equals 180 degree. So based on that, we're going to set up a proportion. This is called proportion. Pi over 180 degree, and in our case, we have 36 degree, and we don't know how many radian that is, right? So it's only x radian. Now here we're going to cross multiply and solve for x. So 180 degree minus x equal to 36 degree minus 5. If you want to omit this degree measurement, I mean the symbol here, no problem, right? That will save some convenience. Okay. That provides some convenience for us to calculate the result. So just dividing 180 from both sides equation. And so that x equal to reduce it, right? 36 or 36, 180 could be reduced by 36 actually. So this is 5, right? Pi over 5. That means this is 1/5 of pi. Yep. Any question about this proportion? Right, that will help you get the radian measurement fairly quickly. 1/5 pi. Yep. Let's see. Let's try this really quickly. Turn a 10 degree to radian measurement. go over the solution here one more time. We get a pi is equivalent to 180 degree. Now we only have 10 degree. So 10 on the bottom. We don't know how many radian, x radian. So 180 times x equal to, let's skip this sign here, equal to 10 pi, 10 times pi. And divide 180 from both sides of the equation, it's equal to pi over 18, right? So it's 1 over 18 pi. That's how you do the conversion between the degree to radian. 1 over 18. Okay. Now let's look at the next question. This is all basic stuff, but it's very useful. It's very important. 180 is equal to pi, right? So I'm gonna skip this. That's okay. What if it's a minus angle? Negative angle? It's similar, right? We do very similar thing. Just set up proportion and then solve for the angle in the radian measurement. Very similar, we will do this. Pi is equal to 180 degree. Right, then we have 444 minus 144 and put it on the bottom. We want to find out how many radian that is, right? And just cross multiply and solve for x. So we get 180 x equal to minus 144 pi. And divide both sides of the equation by 180. And both of these could be reduced by 36, right? On the right hand side. 144 by 36 is minus 4. And this one, 180 divided by 36, that's 5. Yeah, so this is equal to minus 455. Okay, that's how you convert the negative angles. No major difference. So you guys try another one. Okay, try this 488 degrees. Let's go over the solution. So again, we do pi over 180. Is equal to x over 288. And cross multiply and then solve for x. So 180 times x equal to 288 pi. Divide both sides of the equation by 180. Cancel that x is by itself. Now divide both top and bottom by 36. 288 by 36 is 8. 180 by 36. That's fine. X equal to this minus, right? Forget to put a minus sign. So carry over the minus sign, so it's minus 8 over 5 pi. Any question? So -8. Let's try. Check the answer. That should be good. Let's look at the next question, right? Converting y degrees to radians. Y degrees. So you're just gonna write the answer as a y, right? With a y, that's all. Let me show you why. Just gonna be y over y times pi over 180, right? So y over 180 then. You set up a portion and solve it, you end up with this. Y over 100 proportion, right? And then when you converting the radian measurement to degree measurement, actually it's slightly easier, right? And then you guys forget to 1 second, right? I just probably forget to, yeah, I did. I forget to change that into. So just one question. So that's question 3. No, 5. Yeah, this one. All right, let's show me another. So anytime you're converting the radian measurement to degree measurement, you just replace pi with 180 degree, right? That's all. So that's a lot quicker process. So because pi equal to 180 degrees, going back here, replace pi with 180 degrees. So it's a quarter times 180 degrees. 180 by 4 is 45 degrees. So the answer is 45 degrees. All right, so just show me another. What is 5 over 12 pi? Okay, you try this really quickly. Okay, so we replace a pi with 180 degree. So we get 5 over 12 minus 180 degree. And you can make a fraction, right? With 5 cos, you get 900 degree over 12. 900 by 12, 75 degrees. So this is 75 degrees. So it's easier, right? Compare to transferring of the degree to radian, converting radian to degrees, so log frequency 75 degrees. Okay. Let's look at next one. Yes, so it is negative, right? Just minus angle, that's all, right? Like this one is minus 60 degree. And minus 5 over 5, that's 180 over 5, that's 36, right? So this is negative 36 degree. So this is straightforward. So let's just skip this. Here, this is conversion of the radian to degree. Again, it's very straightforward. And this one, this is something that we're going to talk about. So we have the right triangle here because C equal 90 degree, right? That means this is the right triangle and Pythagorean theorem applies. Right, so let me do the screenshot, share screen. Now, in a right triangle, Pythagorean theorem applies. Pythagorean theorem basically C squared, A squared plus B squared. So that's sort of right triangle, right? Doesn't matter. And this is a 90 degree angle. And C, this is 9 degree, C equal 9, A equal 3, right? They want to find out B. What is B? As soon as it's right triangle, then the Pythagorean theorem applies. Now here you replace C with a 9 squared equal to 3 squared of B squared. 9 squared is 81, equal 9 plus B squared. I subtract 9 from both sides of the equation, and B squared equal to 72. So B equal to square root of 72. Here, we're going to simplify this. 72 equals 36 times 2. So 36, 6 right over 2. Is 6 right over 2. Any question about this? So the answer is 6 square root of 2. And now let's try another one, right? You guys try this. Give it a shot. And let's go over the solution. One more time, you draw the right triangle first. And then C is here. C is 7 unit. A is 4 unit. And B, that's what we're looking for. So based on the Pythagorean theorem, C squared equals to B squared, A squared plus B squared. We see with the 7 squared equals to A squared is 4 squared plus B squared. So this is 49 equal to 16 plus B squared. Subtract 16 from both sides of the equation. And so that B squared equal to 33. And then B equal to square root of 33. Then we can now simplify, so we're going to leave it as is, square root of 33. Yeah. Don't bring the answer yet. Check the answer. Yeah, that's good. All right, let's try this. So this is 30, whatever two sides, right? Consider 30, 60, and 90-degree angle when the short side is 9 units. Okay, so yeah, that's it. You guys try this. We did something similar earlier. So you give a shot. Yes. Short size 4 units. And find out the other two sides. Medium side and long side. Let's go over a solution. So 30, 60, and a 90-degree angle. This is 30-degree, 60-degree, 90-degree angle. Shortest side will be this, right? And the longest side, the long side will be the twice as the short side, right? So will be 80 units. And the only thing we don't know will be this side, right? And median side. And we use a Pythagorean theorem, solve for b. So a squared equal to b squared plus 4 squared. So a squared 64. So b squared plus 16. And subtract 16 from both sides of the equation. And b squared equals 48. Now taking the square root from both sides of the equation, b equal to square root of 48, 16 times 3. So it's 4 radical 3. Median side 4 radical 3. The long side will be a unit. Okay. Any question? Yeah, it's all good. This one, the median side is my unit, right? And you don't know the short side and long side. How do we do that? All right, guys, we're gonna go over solution. We'll come back from the break. Okay, let's take a 30 minutes break. Come back on 10:45. All right, guys, let's resume. Okay, so let's complete that question. From Luma, so, Luma home system. All right, so this one's given a median side. So for the graph first. So median side will be the adjacent side of this angle. This is 5 units. So the 30-degree angle, so this is 30 degree, 60 degree. So opposite of the 30-degree angle, assume it's x, right? And then the hypotenuse will be twice as x, 2x. Based on this relationship, and then also assumption of the variables, we can set up the equations of x. So 2x squared. So c squared equal to a squared, b squared. Yeah, so the a squared is x squared plus 5 squared. And then we're gonna solve for x right here. So we get 4x squared equal to x squared plus 25. Now we're gonna subtract x squared from both sides of the equation. Get 3x squared equal to 25. From there, divide 3 from both sides of the equation, we get x squared equal to 25 over 3. X equal to square root of 25 over 3. So we get the square root of 25 over square root of 3. That is 5 over radical 3. I'm going to rationalize this by multiplying radical 3 here. So this is about 5 radical 3 over 3. So this is short side, right? Short side is 5 radical 3 over 3. And the long side will be twice as much. So 2x equals 2 times 5 radical 3 over 2 times 5 is 10. 10 radical 3 over 10 radical 3. Yep, so that's. Any question about this? Short side 5 radical 3 over 3. And the long side 10 radical 3. Let me out. Side first. Yeah, I checked. Both are good answers. Any question? Oh, so let's look at next question. 45 degree. Okay, so you're gonna try this, but this last question. The long side 7 units. You want to find a short side and a median side. No short side, right? Both sides are the same. So two equal sides, right? 45 degree angle give us two equal sides. I'm gonna find out those two equal sides. Okay, give it a couple minutes. Try this. And let's go over the solution. What about you draw the right triangle? And this is 45-degree angle. We call this isosceles, right? Isosceles triangle. And this is x unit. That will be x unit. It is 7 unit. Based on this, we're going to set up the equation and solve for x. So c squared equals to a squared plus b squared. And from here, we get 7 squared x squared plus x squared. We get 2x squared equals 49. Now divide 2 from both sides of the equation, we get x squared equals 49 over 2. So taking the square root on both sides of the equation, actually put 2 square root of 49 is 7 over radical 2. Now we're going to rationalize this by multiply radical 2 radical 2 to 7 radical 2 over 2. So that means both sides are 7 radical 2. That's any question about this? Now check the answer. It should be good. Okay. So we finished the first section, 10.1. And I also want to mention a couple of things right before we move on to section, which is the supplementary angle and the complementary angle. I'll just use one quick diagram to show you what is a complementary angle. So basically, complementary angle so the combined total will be 49 degrees, right? Let's say this is no combined total will be 90 degrees. And this is an angle, let's say angle A, this is angle B. So for complementary angle, angle A plus angle B will be equal to 90 degrees. For supplementary angle, that will be 180 degrees, right? So let's say this is angle A. So probably use this is angle. This is A, this is B. This is A, this is B. When you sum up those two angles, the total will be 80 degrees. And a complementary angle is very, very useful, right? We're going to use it to tackle a lot of problems in a right triangle. With the right triangle trigonometry, right? We're going to see that in a second, especially when we go back to reference angle. We talk about reference angle and complementary angle becomes useful term. Reference angle. We're going to talk about that later, right? About the reference angle. When we get to that point. Okay, any question about this? So now let's get down to 10.2, which is an exercise. On 10.2, trig functions. Okay. And this is getting a little bit more interesting. So let's see. The terminal and the rate of the angle theta, right, passes through the point 4,3. So this tells us we're going to draw this in a Cartesian system. So I'm going to show you how to do this. Terminal angle. So we're going to find out all 6 trigonometric identities here, right? Trig values. So let's first share review. Now, first of all, this angle is located in the first quadrant, right? How do we know it's first quadrant? We draw the Cartesian system, right? Now, let's pinpoint the angle theta in the Cartesian system. So here, this is x value, that's y value. So this is 1, 2, 3, 4, 4 units. on the x-axis, on the y-axis is 3 units, 1, 2, 3. And then we get this, right? This is the where the point is located. The next thing you're gonna connect it to the origin, right? And this is gonna form an angle theta right here. This is angle theta. Okay. Now from here, we're just gonna draw this right triangle, right? Form a right triangle at this spot. So now we know this is 4 unit, this is 3 unit, right? And we don't know C, but we can figure out that from the Pythagorean theorem. And also, I'm going to show you one of the mnemonics, right? It's all called all student study calculus, right? You probably hear this maybe from your high school teachers and maybe other teachers or school, all students take calculus. So A, S, G, and C, right? Meaning in the first quadrant, all 6 trig identities are positive, all positive. And the second quadrant, only sine and cosecant, right? If sine, S represents sine. Sine is positive, then cosecant is positive, right? Because cosecant theta equal to 1 over sine theta. Right? So that's kind of like the relationship. They are reciprocal. This is called reciprocal relationship between these 2 trig identities. Similarly, secant theta equal to 1 over cosine theta. So if the cosine positive, then the secant must be positive. Tangent, cotangent, very similar. Tangent theta is 1 over cotangent. So these 3 are what we call the reciprocal properties of trig identities. So in the second quadrant, both sine and cosecant positive. On the third quadrant, tangent, cotangent positive, right? Tangent positive, cotangent positive. In the last quadrant, the fourth quadrant, so we call this counterclockwise, right? This is counterclockwise. It's not clockwise, it's counterclockwise. It's going the opposite direction of the clock. And then fourth quadrant, so this is quadrant number 1. This is quadrant number 2, quadrant number 3, and then quadrant number 4. And this is very, very useful later, right? When the point is located in different quadrants, then we use this to identify the positive results, okay, from the 6 trig identities. Yeah, so for the fourth quadrant, C, right, represent cosine. Cosine is positive, that means secant is positive. Right, the rest of them will be negative, but this only identify the positive ones. And then we can say the complement of the positive ones is the negative ones, right? So we can easily identify the negative ones from here. Okay, so this is again is a lot of background information. Just want to review with you before we jump into the actual calculation. So right here in this right triangle, C squared equal to A squared plus B squared. A squared is 3, and then B squared is 4. So it would be 4 squared plus 3 squared. And we know that 3, 4, 5, right? That's a 3, 4, 5. That's one combination. 5, 12, 13, another combination, right? And then we have a whole bunch of the different combinations. Those 2 are popular ones. If 2 short sides are 3 and 4, then the long side will be 5. If 2 short sides are 5 and 12 units, then the long side will be 13. So here C squared equal to 16 plus 9, which is 25. C squared equal to 25. C equals square root of 25. C 5. That means C 5 units. Okay, C equals 5. Now we can do sine, right? Sine of this angle theta will be the opposite 3 over a hypotenuse 5. So sine theta is opposite over hypotenuse. OPP, right, represent opposite and opposite of the angle theta. Hypotenuse is it's like right next to, right, is neighboring on the long side, right, which is neighbor of the angle theta. That's hypotenuse of the angle theta. That's 5 units in this case, so it's 3 over 5. Cosine theta is the adjacent. It's the adjacent side of the angle theta, which is the shorter side, right, of the angle theta, compared to the hypotenuse and over hypotenuse. So this adjacent 4 units over hypotenuse 5 units, 4 over 5. And this is located in the first quadrant, right? We know that everything is positive. All 6 of them positive. And tangent theta is opposite over adjacent, adjacent. And that will be opposite 3 units over 4 units. And a secant will be the reciprocal of, if you want to use a reciprocal, right? Secant is a reciprocal of a cosine. It will be 5 over 4. Also, secant is, secant is hypotenuse over adjacent, adjacent. So that's for angle theta. And then let's move on to cosecant, right? Cosecant will be the reciprocal of the sine. Reciprocal of this, so it's 5 over 3. Also, cosecant is the theta, is the hypotenuse over opposite. If you want to go by the definition. And then cotangent is adjacent over opposite. Adjacent in this case will be 4 units over 3 units. You can also use the reciprocal of tangent, right? Reciprocal of 3/4 will be 4 over 3. Okay. And that's basically how you handle this. Any question about this? Okay, so let's put in all the answers. Yeah, 3 over 5, 4 over 5, tangent 3 over 4. Secant reciprocal of cos, secant 5 over 4. Cosecant is reciprocal of sine 5 over 3. And cotangent is reciprocal of tangent 4 over 3. And check it. It should be all good, right? Now let's you guys try another one. Let's see. All right, so now is the okay. This is slightly different, right? Again, this is I guess this is there's a value change. Okay, let's try this one. Let's try this one. So again, always pinpoint down the angle first. So by nail down the coordinates, right? Use the coordinates, and then let's determine where is angle is located. Okay. So now first step, I'm gonna get you started by drawing a Cartesian system, and then we put in the both coordinates. So x value is 4 units, and y value is -3 units, but it's on. So it's 4 units, 1, 2, 3. Okay. This is -1, -2, -3. So the point is right here, down below here. So you're gonna connect them. Now you form an angle right here, theta, right? Now you know that you're gonna draw this to form a right triangle here. So this has a right triangle. And we can use Pythagorean theorem. So this is 4 units, right? And this is -3 units. Now this is important. All students take calculus. In the fourth quadrant, cosine and then cosecant are positive. Everything else negative, right? Now you guys try this. It's almost the same, right? Like what we did for the example. And you try this very quickly. All right, guys, let me do a quick survey here. How many of you guys are freshmen at the BMCC? Any freshmen?
I am.
Yeah, Mister,
am.
I'm
Me.
freshman.
I'm
Okay.
also a freshman.
Okay, very good, guys. So I just received an email from Professor Lawrence, and she mentioned that if you're a freshman, if you fail the final exam, right? For this course, for our course between 50 to 59, you have another chance in the immersion 3, meaning you'll be recommended to immersion 3 and taking the course again, taking the course over in immersion 3. But I want you to finish this, in the section 2, so you don't have to take another session of this. I think immersion 3, it's 9 days intensive workshop. But try your best in our program. So finish this and pass it, and then you can enjoy the summer. Okay. Still have a month to go, right, in the summer, so you don't have to worry about this stuff. Yes. Any question about this? But I will keep a note if you're a freshman. I will keep a note if you fail the final. I will recommend you for the immersion 3. Immersion 3 is from July 31st to August 15th. And yeah, so it will be June, there will be June student orientation on Tuesday, July 30th. At 9 a.m. and 8:30. So again, there's morning section 8:30, 12:30. I'm also going to be teaching immersion 3. So so if you yeah, so definitely this is another opportunity. But my suggestion is to try your best in our section, knock it out, so you don't have to worry about it, for the rest
What's
of the
a
summer.
passing grade in the final?
Final will be 60. I mentioned that last time. So they in a regular semester, right? That's why I remember it was 70. I teach that a couple of times in the regular semester in the past. It was passing grade was 70 though in the final exam. But because this is the summer immersion program, so they lower the standard a little bit for you guys. So your passing score is going to be 60. So that's 60 is doable. It's totally doable. 70. Even I teach that course, a lot of I think majority of my students pass. If they attend the class every day, do all the work, I think it's more than 90% of my students pass. So it's pretty doable. And then now again, you only need 60%, right, to pass. Okay, so definitely it's a good news for you guys. So let's go back to that question. And do you finish yet? Let's All right, let's go over the solution here. So again, sine theta is, first of all, this side will be 5 units, right? It's 3, 4, 5. Okay, so that's always the proper combination. This is 5 units. And you always make this side positive, right? And then the sign of these three identities will be determined by this value here. Right, so by the opposite side, which is -3 units. So sine is a negative, right? So in this fourth quadrant, this is fourth quadrant, first, second, third, and fourth. Both only cosine and secant are positive, everything else is negative. So we use that as a guiding principle to get our result. So sine theta is -3/5. So -3. Cosine is adjacent over cosine is positive. Adjacent 4 units over hypotenuse 5 units. Tangent theta is opposite -3 over adjacent 4. Real. Secant theta is reciprocal of cosine, so 5/4. Cosecant theta is reciprocal of sine and 5/3. Cotangent theta is reciprocal of tangent 43. Right, so any question about this? Okay. Sine is -3/4 over 5 here. Cosine 4/5. And tangent will be sine over cosine, right? Tangent theta equals sine theta over cosine theta. So -3/4. So basically, if you get sine, cosine, you can get the rest of them, right? And the secant will be the reciprocal of the cosine, so it's 5/4. Cosecant is the reciprocal of sine, so it's -5/3. Cotangent is the reciprocal of tangent, so -4/3. So if you know just sine, cosine, you can find the rest of them using the trig identities. And it's all good. All right, let's look at the next problem. This one is similar, right? Very similar. 5, 12, 13. I'm just gonna let you try that. Show me another. Maybe one of these. Let's try different from different quadrants here. Yeah, let's try this one. This one is from the third quadrant, right? Both negative. Okay, I'll give you some time to try this. Now let's go with the solution here. One more time, we're gonna do this. Put it into the Cartesian system. So this is -5, right? X value is -5. 1, 2, 3, 4, 5. And then Y value is -12. So 1, 2, 3, 11, 12. And it's 12. And based on this, we can figure out the, so this gives us the current coordinate and pinpoint down the point here. Now connect it. Now this right here is what we call the reference angle. This angle is called reference angle theta. So reference angle, it's always a Q angle, right? Always between theta is always going to be greater equal to 0, less equal to 90 for the reference. Not a Q, it's going to be between 0 and 90 degrees. In this case, it is. And this is -12 units, this is -5 units. 5, 12, 13, right? This is 13 units. We can use a Pythagorean theorem, c squared equals to -5 squared plus -12 squared, and c squared equals 25 plus 140. C squared is 169. C is the square root of 160. C is 13. Square root of 169. And then the C is always going to be positive. We always keep the positive answers here. 13. Now we know that all students take calculus. So in the third quadrant, tangent, both tangent positive, or tangent positive, right? Everything else negative. Now we can start calculating this. Sine will be opposite, -12 over 13 over hypotenuse. Okay. And then cosine will be adjacent, -5 over 13. Tangent is going to be opposite over adjacent, -12 over -5, those will be 12 over 5. Secant is reciprocal cosine, -13 over 5. Cosecant is reciprocal sine, -13 over 12. Cotangent will be reciprocal tangent, 5 over 12. As you can see, only two values are positive. Tangent positive, cotangent positive. And everything else is negative. Any question about this? The first one is -12 over 13. Cosine is -5 over 13. Then tangent positive, 12 over 5. Tangent equals sine over cosine, 12 over 5. And secant is reciprocal cosine, so it's -13 over 5. Cosecant is reciprocal sine, -13 over 12. And then cotangent is reciprocal tangent, so it's 5 over 12. So that's all the answers. Okay. Any question about this? Yeah, so this is another type of questions that it tells us which quadrant the angle is located, right? I'm going to show you how to do this step by step. So this is the third quadrant. I'm going to try a different second. We haven't tried anyone with the second quadrant. This is second quadrant, so it's good. So this angle, terminal rate of angle, so angle theta is located in quadrant 2. Now we want to find out if sine theta equals 15 over 17, compute the rest of the three identities, right? Now, first of all, right here, let's draw this. This angle is in the second quadrant. So
that's second.
we go here, and this is going to be the second quadrant. So the theta is here. Now, we know a couple of things, right? We know sine beta is 15 over 17. So this is 17 units. Opposite is 15 units. That means this is 15. And then the only thing we don't know will be adjacent side, right? We're assuming this is A. We don't know A yet. So we're gonna figure out that. In this case, because it's in the second quadrant, so A is gonna be negative, right? As you can see, A is gonna be definitely minus. When we take the square root, we only keep the negative values here. Now let's do it. Try so it will be c squared equal to a squared plus b squared. C squared 17 squared equal to a squared plus b squared. 17 squared, that's 289, right? Let me double check. 17 squared. Yeah, 289. 289 with a squared plus 225. 15 squared is 225. And subtract 225 from both sides of the equation. A squared equals 64. The A must be minus, so 64. Because must be negative, so it's negative 8. A is negative 8. So this is negative 8. Because it's an A equal to negative 8. In the second quadrant, here the x value is negative. The y value is positive. Right, that's good. This is positive. Now, once we figure out this, then we can do the, and we know that in the second quadrant, all students, right? Only sine positive and then cosecant are positive. Now, so sine is positive, we know that. And then cosine is going to be adjacent, negative 8 over hypotenuse. Then tangent theta is opposite over adjacent, so negative 15 over. Secant is reciprocal of cosine minus 17. Cosecant is reciprocal of sine, so 17 over 15. Cotangent is reciprocal of the tangent, it's minus 8 over 15. So out of this, sine positive, cosecant positive. Any question about this? Put the answer. Minus 8 over 17. So cosine and tangent is sine over cosine, so it's minus 15 over 8. Secant is reciprocal of cosine, so minus 17 over 8. Cosecant is reciprocal of sine, so 17 over 15. And cotangent is reciprocal of tangent, so it's 8 over 15. Yep, so now we check it. Should be all good, right? It's all good. Let me see next problem, maybe similar, so you can try the next problem. Let's go to next problem. Yeah, it's very similar. So let's try this problem here. So I'm gonna put in a new, so third problem. Let me see. You guys can try this, right? All right, let's go over the solution here. So this is in the quadrant 3. So you're gonna put in the third quadrant here, and then cosine is, so the angle theta is here. This is a reference angle theta. And for this adjacent is going to be -8. That matches because it's the third quadrant, x value is negative, and 17. And then also the y value here should be negative as well. So this b here must be also negative. And let's use Pythagorean theorem to get the value of the b. So it's going to be 17 squared equal to b squared plus a squared. 17 squared is 100. B squared is negative a squared. That's what we're looking at there. B squared is over there. This is 64. That's 64 from both sides of the equation. The b squared equals 225. And then we only gonna take the negative values because it's in the third quadrant, right? Both x and y are negative. So b must be negative. So b equal to minus square root of 25. 225 is 15 squared. Actually, b times minus 15. Again, a 15, 17. B is. Now, once you nail down the value of the b, then we get the rest of them. Sine will be the opposite over hypotenuse, minus 15, 17. And the third quadrant, only tangent positive, cotangent positive, everything else negative. Let's see, so tangent will be the opposite over adjacent, so minus 15 of 8, which is minus negative 8, will be 15 of 8. Positive, right? Secant is a reciprocal of the cosine, secant is reciprocal of this, minus 17 of 8 minus. Cosecant is reciprocal of this, minus 17 over 15. And cotangent is positive. Will be the reciprocal of this, a over 15. That's how we nail down all the values here. Let's put back the answers. Sine is going to be minus 15 over 17. Tangent is sine over cosine, so 15 over 8. Secant is 1 over cosine minus 17 over 8. Cosecant is reciprocal of this, minus 17 over 15. Cotangent is reciprocal of this, a over 15. Yeah, so that's correct for all of them. Any questions? All right, let's move on to next question. Yeah, so this last question, 1 and 1/3. It's very similar, right? No difference. Let's see. Yeah, so this one is given tangent, right? In the second problem. That's right. Okay, let's go over this solution. But again, it's in the second quadrant. I'm going to draw this, and then it will be here, right? And the reference angle is always the angle theta. This terminal side intersect with the x-axis. So this is where the angle is located. And sine is -5/12, right? I think I didn't draw a good graph. Let me just redraw this. Should be this. And this is angle theta. And assuming the tangent is opposite or adjacent. In the second quadrant, you know, the y value is positive, right? So this is positive, this is negative. So the opposite will be positive. So 0.5 units, and the adjacent side will be -12. And based on this, we're gonna find out the hypotenuse side, this side, C. So C squared equal to A squared. C squared equal to 5 squared. Adding -12 squared. And this is very important to determine the sign of the those two sides, right? This is very, very important. So based on the Cartesian system, quadrant 2, the y value is always positive, right? X value is always negative. So C squared equal to 25 plus 144 makes 169. So C equal to 12 of 169. So this is 13. Now, once we nail down that the C value, then we can start properly arrange the sign. And the rest of them will be straightforward. Sine will be the opposite over hypotenuse power 13. Second quadrant, sine is positive, and then cosecant is positive. So we see sine is positive, matches. Cosine will be the adjacent over hypotenuse, that's over 15. Negative. Secant is reciprocal of cosine, so -13 over 12. And the cosecant is reciprocal of the sine, 13 over 5. Cotangent is reciprocal of tangent, which is this, -12 over 5. Yeah, so that will give us all the correct answers here. Any questions about this? Problem 13 is sine, cosine, -12 over 13. And secant is reciprocal of the cosine, -13 over 12. Cosecant is reciprocal of sine, 13 over 5. And the cotangent is reciprocal of tangent, 12 over 5. And that should be all good. Yep, that's everything on section 10.2. So we basically tackled all 6 fluid identities for different type of scenarios. A Cartesian system, right? 4 different quadrants. And let's move on to 10.3. Trigonometric function, and then calculations from there. And then using it, also we're going to learn how to use a calculator to handle some of the trig operations. And tomorrow we're going to cover chapter 11 and a little bit of a chapter. So we only have 2 sessions left. After this will be 12.1 and then 1101 trig identities, 1201 solving right triangles, and that'll be everything for in terms of lecture. Now let's take a look at evaluating trig functions. So this angle is 315 degrees, and find a reference angle. So this is one of the questions that we have to find the reference angle. Let me show you how to do this. And reference angle is what we use to do the calculation for the trigonometric identities. Okay, let's get started. Okay, so 285 degrees. So this is so going counterclockwise, right? Counterclockwise this way. X or Y. So this first quadrant gives 90 degree. This is 90, 180, 270. So that means reference angle will be located in the fourth quadrant. And then we know this is already 270 degrees. Then we have 285. So it's going to be 285 degrees minus 270 degrees. Right, so that means this angle here is 15-degree angle. But it's not the answer yet, right? The reference angle is always the angle. We call this angle theta is a terminal sine intercept with the x-axis. So this angle here, we're going to use a complementary angle concept. Complementary angle. Meaning this 15-degree adding theta is going to be equal to 90 degree, 15 degree plus angle theta equal to 90 degrees. Let's take 15 degrees. Theta, angle theta, reference angle, it's going to be 75 degrees. So this is the reference angle. Okay, always, right? It's terminal sine. This is called terminal sine. Intercept with the x-axis, not a y-axis. It's always x-axis. Reference angle is formed by terminal sine. X-axis. Any question? So theta is equal 75 degree. Okay, 75 degree. Or you can also do this. You can, another way, answer is good, but I'm going to show you another way of doing this. You know that the entire angle here is, I mean, the one cycle is 360, right? If you subtract the given angle, you get a reference angle. Total is 360 is one cycle. Subtract 285 degrees. That gives us 75 degrees. That's why the answer here is 75 degrees. So this is another way, probably slightly quicker to get into the reference angle. So I let you try one of this. Try this, right? Let's find the reference angle for theta equal to 135 degrees. Okay, so let's go over solution. So here 135 degree will be this, right? This is 135 degree. And the reference angle will be this angle here. They use alpha, so this theta equal to this. So we use the symbol alpha. And we know alpha plus theta is going to be 180 degrees. This is a typical supplementary angle. And then theta is 135, so alpha plus 135 degrees, 180 degrees. So alpha equal to 45 degrees. And 45 degrees is what we call a reference angle. Yep. So 45 degrees. So that's the answer. Any question about this? Okay, let's look at the question number 2.
It has to be like the x-axis. If it's like around the right side, left side.
Yeah, always. It doesn't matter, right? Just gonna be the x-axis. It could be left-hand side or right-hand side, but it gotta be this x-axis.
Whichever is closer, right?
Closer. What do you mean by closer? It's one more time.
Like it, in the first question, it was in fourth quadrant, and the nearest x-axis was on the right hand side, but now it's in the second quadrant, and
Yeah.
it's nearest to the left hand side. So
Exactly. So the second and third, right? It's always gonna be, if the second and third, it's always on the negative side.
yeah,
If the first and fourth will be positive side. Very good question though, Alva. This is a very good point, right? Very good, very good observation. Only second or third, it's gonna intersect with the negative side of the x-axis. If this first quadrant and then fourth quadrant, let me stop using the Greek letters. Second, third, intersect with the negative side, and then first and fourth intersect with the positive side of x-axis. But yeah, that's exactly how that goes. Very good. Two different type, right? Two different type of the reference angle. Okay, next problem. What if it's a negative angle? Okay, so going counterclockwise, we get positive angles, right? So if we go clockwise, we get negative angles. So let me show you how to get this, how to find out the reference angle if it is negative angles. Now again, you draw the Cartesian system, and then we just visualize from there step by step. So right here, draw this. This is counterclockwise, right? But now we're gonna do clockwise to get a negative angle. So meaning going this is 0 degree here. Which is starting point. 0 degree, right? This is 0 degree. Now minus 60 is right here. This is minus 60, meaning this is 60 degree. Okay, so that means a reference angle is gonna be, although it's minus 60, right? Because it's rotating clockwise, so the angle is negative. But in terms of reference angle, must be reference angle always positive. Reference angle always going to be positive. Always positive. So that's why, although it's angle-wise, right? Because of direction we are moving, it's negative, but the reference angle is 60 degrees. All right. Any question about this? So this is going to be 60. And this is a tricky part about reference angle, right? Because it's a little bit, you got to be a little bit flexible to tackle this type of. You might get one with 100 something. Yeah, if this will be Yeah, this is not, okay, let's get to the next problem. We probably with a, if it's located in the third quadrant, we always get a fourth quadrant one. Let's look at the, yeah, this is the one I want. Okay, let's try this. Okay. If the angle is minus 195 degrees, find the reference angle alpha in degrees. And this one is located in a, I'll let you find out yourself. Okay, let's look at the solution. One more time, this angle is located in the second quadrant, right? If you draw it going clockwise this way, so this is 180 already, and then 195, right? Will be somewhere here. So meaning this angle here will be 195 degree minus 180 degree, which is a 15 degree angle. So reference angle alpha is 15 degrees. Again, it must be always positive because it's reference angle. Yeah, again, it's an intercept with the negative side of the x-axis. This is positive side. Because it's located in the second or third quadrant. And second quadrant, in this case, the reference angle 15 degrees. Any question about this? Check the answer, it should be good. Okay, let's move on to next. Yeah, so we're gonna start learning how to calculate trigonometric values, like trig values for different type of trigonometric identities. This is cosine 240. So let's look at this cosine 240 degrees. Let me show you how to get this done step by step. Let's start with the reference angle. You need to locate the reference angle first. So 240 degrees. This one is going counterclockwise. So that means we're gonna go this way, right? This is 180 and 240, right? Somewhere here. And then that means a reference angle here will be 60 degrees. And then we know cosine, this is the same thing, equivalent to cosine 60. However, this is on the third quadrant, so all students take calculus, right? In the third quadrant, cosine is minus So that means this will be equal to minus cosine 60 degree. Right. And cosine 60 degree, we really already, if you draw a right triangle, this is 60 degree, and this is the 1 unit, this is 2 unit, this is 30 degree, right? Divided for 3 units. Then determine the sign is minus, right? We know because it's in the third quadrant. And based on the 30, 60, 90 degree triangle, special triangle, we know that cosine 60 is going to be adjacent over hypotenuse, right? So it's half. So the answer is negative half. Any question about this? 2 steps. Determine the sign based on the guiding principle. All students take calculus. Based on that, we determine the sign first. Then second step, usually we use the special triangle, right? Use the special triangle to get a value. So that's how you tackle this type of problem. All right, so the answer is negative half in this problem. Okay, you guys try another question here. Cosine 300 degrees. Let's see. Okay, let's go over the solution. This one. But again, let's locate the reference angle here. 300 degrees. It's going to be located in the fourth quadrant. This is 270, right, all the way to this, and then 300. So in terms of finding the reference angle, we can use full circle this is 300 degrees. We're doing 360 minus 300 degrees. That's 60 degrees. So that means its reference angle is 60 degrees. And it's located in the fourth quadrant. All students take calculus in the fourth quadrant. Cosine is positive. This is the most important. Determine the sign. And so it's positive, right? And then the reference angle is 60 degrees. And we just find out cosine 60 degrees is half. So the answer is maybe half. From the previous question. So any question about this? Okay, next, take a look at next question. Tangent 300. Okay, tangent, let's see tangent. Tangent 100 degree. Yeah, that will work. All right, so I guess I'd like to try really quickly before I go over the solution. Again, find the reference angle. Determine the sine. And then look and figure out the value. Okay, let's go over the solution. One more time, let's locate the reference angle first. So let's go through the process. 120 degrees is located in the second quadrant. So this is 120 degrees. And this is the reference angle we need. So we're going to use 180 minus 20 degrees, so it's 60-degree angle here. Now from there, we're gonna determine tangent, right? So all students take calculus. In the second quadrant, tangent is determine the sine, right? So this is gonna be minus, and then using the reference angle, tangent 60. And you can quickly draw the right triangle and 60-degree, 1 unit, 3 unit, right over 3. So the tangent 60 will be the opposite over adjacent, so it's minus radical 3 over 1. So it's minus and radical 3. All right, and any question about this? So the answer is minus radical 3. Yeah, check it. It's the correct answer. Let's look at the, I'm gonna go over one more question and let you guys go. All right, let's look at this question here. Another, given this sign, right, and then it's located in the second quadrant. And I try a different one. Yeah, let's try this one. I'll give you a couple minutes to look at this. All right, let's go over the solution. So they told us angle theta is in the second quadrant, and then it's radical to in the second quadrant, sine is positive. This is okay. Now we just need to locate the theta, right? So we know for sine theta to be radical 2 over 2, theta must be 45 degrees. Meaning reference angle is 45 degrees. And then it's in the second quadrant. So you can draw it, right? Based on the special angle. It's a special angle. So that's, so it'll be this. And we know that this reference angle is 45 degrees. Now we know
We
the
did-
angle itself.
Saccharin.
Yeah, so it's 135, right? So you do 180 minus 45 degrees, 135 degrees. That's the angle we're looking for. With a reference, only this one has a reference angle for 45 degrees. So this is the angle we are locating. It's sort of like going backwards. We have the value, right? But we don't know what the angle is. So we're using this reference angle first, using a special value of the angle, and then locate the reference angle. And then after that, find the angle with the 45-degree reference angle. So the answer is 135 degrees in the second problem, right? That makes sense. Any question about it? It's a correct answer. Now, so basically you guys gonna finish homework 10.1, 10.01, 10.02. And we are in the middle of the 10.03. We're gonna finish 10.03 tomorrow morning. And then finish the other two sections tomorrow. And then on Wednesday, we're gonna review for the final exam. So today's homework will be these two, right? And then half of the 10.3, so these three. Half of it, 10.3, okay. And before we end the section, do you have any questions?